All right, today we're going to start module 4, and we're going to work on lesson 4.1, which is graphing linear functions. Today we're going to focus on function tables, being able to make a function table, and then given a function table, determine the rule that was applied to it. We're going to look at the concept of ordered pairs and them being solutions to linear equations and what that means. And then we're going to do some graphing of horizontal and vertical lines today. Okay. So first of all, a little bit about graphing linear functions, and we're going to use tables here to start with. All right. So when we use a table, basically this table of values that we're going to generate using a rule is going to guide us to the graph of the linear function. Every ordered pair that makes the equation 2 represents a point on its graph. So every ordered pair that is in this function table, when plotted, will be on the line that represents the graph, and the line itself represents all the solutions. So when you draw that line in a coordinate plane to represent a linear equation, you're really graphing all the answers to it. Every ordered pair on that line is an answer. And then these are all two variable equations. So it'll be y equals 2x plus 3. So you got two variables. So you need to figure out what the x and the y are that make that true. And there's really an unlimited number of answers. There's an infinite number of answers to these problems. Okay. So first of all, completing a function table, we really already done this. All right, they're giving us a function rule, they're saying. So y equals 1 plus 2x is the function rule. We could have also written this as f of x equals 1 plus 2x. That's just our function notation, but this is still a function. Okay, every input has a unique output. That's the idea of a function, remember? So when I'm completing this table, basically I'm taking each input and plugging it into the rule. So y equals 1 plus 2 times 2. X is 2. I'm putting in place of the x. The answer is 5. So 2, 5 is a ordered pair that's on this line. Input of 3. X is 3. I'm going to replace the x with 3. I get 7. So the ordered pair 3, 7, if I graphed it, would be a point that's on this line. When y or x is 6, I'm going to get 13 as my answer. So the order pair 6, 13 is on this line. Okay, when y is 10, 21 is my answer. So an input of 10 gives us an output of 21. The order pair 10, 21 is on the line when we graph it. Okay, looking at my next one here, y equals negative 10x plus 1. Okay, I'm going to do the same thing. Here's my input, negative 5. Negative 10 times negative 5 is 50, plus 1 is 51. Input of negative 5, output of 51. Input of negative 1. Negative 10 times negative 1 is 10, plus 1 is 11. Input of negative 1, output 11. So this ordered pair, negative 1, 11, is on the line. Input of 0 gives us a output of 1. 0, 1 is an ordered pair on the line. And input of 1, output of negative 9, 1, negative 9. If I was to plot that point, it would be on this line. So these are the ordered pairs that are on the line. Okay, they ask us to generate these answers here. We don't have to graph it right now. We just have to generate these. But understand, if I was to plot these points on an XY axis, they would all lie in the same straight line. They're all answers to this equation. Okay. Now the next thing we're going to do is given a table of values, come up with the function rule. Okay. What is it that they're doing every time to take the input and get that output? Okay, so the first thing we look for in these is simple. Are we multiplying it, every input by the same number to get the output? Are we adding the same number to each input to get the output? We kind of start simple. And in this case, it is pretty simple. 4 times 4 is 16. 7 times 4 is 28. 9 times 4 is 36. So the function rule here is pretty obvious. We're going to take every input value and multiply it by 4, and that's going to represent the output. So if I had an input of n, the output would be 4 times n. Whatever that number is, I'm going to multiply by 4, and that's the output. Okay? You can be multiplying by a positive number. It could be multiplying by a negative number, subtracting, adding. That's simple one-step type questions. So you asked to generate that number there. Okay? The second type here is a little bit more complex. It's where you have to do really two steps, a multiplication and an addition or subtraction. So it's kind of a two-step process rather than a one. All right. So if we look here, input of 1, output of -5, input of 2, output of -6, input of 3, output of -7, input of 4, output of -8. And then as I further look, I'm just kind of looking here. Are we consistently doing inputs or are we jumping all over the place? Well, we're consistent. We input 1, then 2, then 3, then 4. So they're consecutive. So that helps us when I look at the outputs because at least I'm comparing the same change each time. Okay. So here, we're going down by negative by 1. So it's -1, -1, -1. And that's helpful. So that tells me there's a negative at play here. So the way we're going to do this is here's my same input outputs: input of 1, output of -5, input of 2, output of -6, and so forth. All right. The first thing we're going to do is use this -1. I'm going to take all of my inputs and multiply them by -1 for starters because I know I got to get a negative in here. So I take 1 times -1, 2 times -1, 3 times -1, 4 times -1. Okay. So these are the answers once I do that multiplication. Now, am I consistently now subtracting or adding a number to go from the given answer to the new answer? Well, -1 minus 4 is -5. -2 minus 4 is -6. -3 minus 4 is -7. -4 minus 4 is -8. So by subtracting 4 after we multiply by -1, I get the outputs they're asking us for. Okay. So the function rule then is I'm going to take every input value, multiply by -1, and then subtract 4. So if I input n, my output would be -1n minus 4. Okay. So that's how that's going to work right there. Okay. And this just takes practice. You got to write this out, look at your results, and then see what consistently can I do to get the answer. Okay. Let's look at another one like this. Okay, same kind of deal. If I look at the input outputs, I don't see any simple subtraction or addition or multiplication I can do, right? 1 to 3 would be times 3. 2 times 3 is not 1, so that's out. So you kind of check the simple stuff first. Once you get past that, then, what I like to do is look, okay, my inputs I'm consistently going up one of my inputs. So how do the outputs compare? Well, down 2, down 2, down 2. I'm going to use this information. Okay. So what I'm going to do is take my inputs now and multiply by that change, -2. So 1 times -2 is -2. 2 times -2 is -4. 3 times -2 is -6. 4 times -2 is -8. Okay. Now that I've done that part of it, how do I go from this answer to 3? Now I'm using addition or subtraction because I've already done my multiplication here. So if I take -2 plus 5, I get 3. Now I should be able to add 5 to all of them if that's truly going to be the rule. -4 plus 5, yeah, that's 1. -6 plus 5, yeah, that's -1. -8 plus 5, yeah, that's -3. Okay, so there's my answers there. So every input has an output and they all match up. So what was the rule? Well, I'm going to multiply first by -2 and then we're going to add 5 and that gives us the input outputs up here. So if I was to input n, my output would be -2n plus 5. Okay. So that's going to take a little work. Practice it a little bit. I think you'll see it and you'll generate these answers. Okay. Now the next concept is identify ordered pairs that are answers or solutions to a given equation. So are any of these ordered pairs that they have listed, are they answers to this equation? In other words, are they points that when I graphed it would be on the line for this equation? Okay. If an ordered pair is an answer to the equation, then when you plug in the values of the ordered pair, so x is -8, y is 4, that should make this true. If it's on the line, then it makes it true. So let's go ahead and do that. Put -8 in place of x, 4 in place of y. That's going to be -32 plus 28. That's going to be -4. Does -4 equal -19? No. So this point, -8, 4, is not on the line. Okay. Check the next point. -4, -5. So take our equation, replace x with 4, y with -5. 4 times 4 plus 7 times -5. 16 minus 35 equals -19. -19 equals -19. That's true. So this combination of x is 4, y is -5, when it's plugged in here, makes it true. Yes, that's a solution. That means this ordered pair, 4, -5, would be on the line. Okay. -3, -1. Same concept. Take our equation, replace x with -3, y with -1. Okay. -12, it should say -19, not plus minus, should be -12 minus 7 is equal to -19. -19 equals -19. That means this ordered pair, -3, -1, is a solution and it's on that line. Okay. 6-2. You got to check them all, guys. If one happens to be right, that doesn't mean the other ones aren't. These could all be yeses. There's an unlimited number of ordered pairs that are answers to this equation. So you can't assume if you get one, you're done. You got to check them all. Okay. So x is going to be 6, y is going to be 2. Okay. I'm going to get 24 plus 14. I'm going to get 38. Obviously, that does not equal -19. So, no, this is not a solution. So, to check to see if an ordered pair is a solution, plug it in. If it makes it true, it's a yes. If it doesn't, it's a no. Okay. This one just says, hey, go ahead and find your own solution to this equation. Name an ordered pair that's an answer to this. Okay. So 5x plus y equals 1. Find a solution. Well, all you're going to do here is choose a value of x. It doesn't matter what you pick because there's an unlimited number of possibilities. Every x has a y answer. So just choose an x. Then plug that x in and solve for y, and you'll have your ordered pair. So I keep it simple here. Let's let x be 1. Okay. When x is 1, I'm going to have 5 times 1 plus y equals 1. 5 plus y equals 1. I'm solving for y now. Subtract 5. Y equals -4. So an input of x of 1 gives us an output of -4. So the answer is 1, -4. This ordered pair, 1, -4, is a solution to this problem. We could all pick a different x and get a different y, and we'd all be right. Okay, just keep it easy on yourself. Here's another one. Find an ordered pair for that makes this equation true. Well, again, choose a value for x, plug it in, and solve it for y. So I just let x be 2 this time. So 6 times 2 minus y equals 6. 12 minus y equals 6. I'm going to subtract a 12. Now you got to catch this. It's negative y equals -6. Okay, 6 minus 12 is -6, and that minus sign in front of the y stays there. So I got to make this is really like a -1 times y. I'm going to multiply both sides by -1, and y equals +6. So an input of 2 gave us an output of 6. That's an ordered pair. That's an answer to this equation. Okay. So when you got a lot of freedom here to pick the numbers you want, make it easy on yourself. Okay, the last concept for today is to graph horizontal and vertical lines. Okay, these are unique. Usually we have a slope and our line is sloped up or sloped down. Horizontal lines, guys, always look like this. Y equals a number. Y equals 2, y equals 7, y equals -8. It's just a y. There's no x. Y equals a number. The equation basically means that all points that are on this line have a y coordinate of this number. Okay, whatever that number is, all of them have a y coordinate of that number. So let's say we were asked to graph the line y equals 5. Okay, the graph y equals 5 is going to be the set of all points that have a y coordinate of 5. So I'm just going to pick a few. Okay, so pick any x you want and put a 5 in for the y. So I went -6, 5, -2, 5, 1, 5, 3, 5. All of these have a y coordinate of 5. Now, if I graph these points, -6, 5, -2, 5, 1, 5, 3, 5, you can see that they make this horizontal line. So these points show us the graph y equals 5. It's a horizontal line, and I always think of it this way too. This is the y-axis, right? The one that's running up and down. This line is going through the y-axis at 5. It's a horizontal line going through the y-axis at 5. So that's how we graph horizontal lines. Okay. How about vertical lines? Well, vertical lines are in the form x equals a number. X equals 2, x equals 8, x equals -3, x equals -8, whatever. Okay. The equation means that all the points on the line have an x coordinate of this given number. So if I was to graph the line x equals -3, Okay, that means this graph of x equals -3 is going to be a set of all the points that have an x coordinate of -3. All right, so I just picked a few. All of my ordered pairs here have -3 for an x, and I just put in a different number for y. It doesn't matter. -3, 4, -3, 1, -3, -2, -3, -5. All of these have an x coordinate of -3. If we graph them, we're going to see the graph. Okay. So -3, 4, -3, 1, -3, -2, -3, -5. They make this line. Okay. This is the graph of x equals -3 right here. Notice that this vertical line is going through the x-axis at -3. Okay. So that's how we graph horizontal and vertical lines. We do it very directly. All right. So tonight we're going to work specifically on those types of questions that we just went over. Okay. Make sure you've written a few things down, have some examples there for you to work from, um, and get your homework complete on Alex. And I will let you have at it.